Hello everyone, this is a quick tutorial on building TensorFlow from source and installing it on Summit supercomputer. We will be installing TensorFlow 1.12 using Python 3.6, CUDA 9.2, cuDNN 7.5 and Nickel 2.4. So let's begin. Let's load the GCC and CUDA modules required for the installation using module load GCC followed by its version 4.8.5 and module load CUDA followed by its version 9.2.148. Now let's create a separate working directory called summit_tf where we will eventually install TensorFlow as well. Let's go inside the directory using the cd command and let's set the versions of the other required libraries and packages as variables. Let's first set the Python version to 3.6, Conda version to 5.2.0, TensorFlow version to 1.12.0. Then let's set CUDA version to 9.2, cuDNN version to 7.5.0. And finally let's set Nickel version to 2.4.2-1 and Bazel version to 0.18.0. And to give you an idea, Nickel is NVIDIA's internode communication library similar to MPI, and Bazel is a build and test tool similar to Make that we will use to build TensorFlow. Continuing further, let's clear the terminal and grab the Anaconda package manager, for which we will use the wget command. So we will do wget followed by the URL to Anaconda's repository, followed by the file name. Once it's downloaded, let's run it by executing bash followed by the name of the installation script, followed by a few flags and name of the directory in which we want to install Anaconda. And let's wait till the installation is finished. Next, let's update the path variable to include the installed Anaconda by doing export path and including the bin directory of the installed Anaconda. And now let's update the pip version by doing pip install upgrade pip. Once it's updated, we will also install Keras applications and Keras preprocessing packages, which are required for using the Keras API with TensorFlow. So we will do pip install Keras applications followed by the version and the flag no dependencies. And pip install Keras preprocessing followed by its version followed by the flag no dependencies. Next, let's build and install Bazel, for which we will use its distribution from its GitHub repository. So let's get its distribution using wget followed by the URL to its GitHub repository. And once it's downloaded, let's unzip it inside a directory called Bazel. And now let's go inside the directory and execute the compile script. Let's clear the terminal and update the path variable to include Bazel's output directory where the Bazel is installed. Let's now go outside the Bazel directory and build and install Nickel. Let's grab its Git repository by running git clone followed by the URL to its Git repository. Once it's cloned, let's go inside the repository and check out the branch version that we have set as variable, which is 2.4.2-1. Now let's build Nickel by executing make followed by the flag j followed by source.build and the path to CUDA home, which is saved as an environment variable called CUDA_dir. Let's wait for the execution to complete. Once the command execution halts, we will run make followed by pkg.txz.build followed by the path to CUDA home. Now let's extract the generated zip file by executing tar followed by the flags x and f followed by the location of the zip file. Followed by the flag C and the location where we want our extracted file. Let's go outside the Nickel directory and now we will have the extracted directory with a name that starts with nickel underscore followed by the version and so on. So let's create a link to this extracted Nickel directory by executing ln flag s followed by the name of the extracted Nickel directory and followed by the link named nickel2. Now let's set the CUDA_dir variable to the CUDA path variable CUDA_dir because CUDA module already contains the cuDNN libraries. Now let's set some environment variables that will help speed up the installation process. Let's set python_bin_path to anaconda3 bin python3. Next let's set python_lib_path to anaconda3 lib python, its version and site packages. After that let's set tf_CUDA_version to CUDA_ver. Next let's set CUDA_toolkit_path to CUDA_dir. Now let's set tf_cuDNN_version to cuDNN_ver. Next let's set cuDNN_install_path to cuDNN_dir. After that let's set tf_nickel_version to 2.4. After that let's set nickel path to nickel2 and finally let's modify ld library path to include CUDA's lib64 stubs. Let's clear the terminal and download the TensorFlow repository from GitHub. Once it's downloaded, let's go inside the repository and check out the version 1.12. Now let's configure the installation by running configure and answering the configuration questions. Since we won't be using Apache Ignite support, we will set this to N. We won't be using XLAGIT support as well, so we will set this to N. We won't be using OpenCL support, so we will set this to N as well. Next, we won't be using ROCm support, so we will set this to N as well. But we will be using CUDA support, so we will set this to Y. Next, we won't be using TensorRT support, so we will set this to N. Next, we will set CUDA compute capabilities to 7.0. After that, we won't be using Clang as CUDA compiler, so we will set this to N. Now we will be using the default GCC compiler, so we will just press enter here. Now we won't be using MPI support as well, so we will set N here as well. Now we will set Basel optimization flags mCPU to power 8 and mtune to power 8 as well. And finally, since we won't be dealing with Android builds, we will set this to N as well. Now let's clear the terminal and build TensorFlow from source by running this Basel build command. Building process will take some time, so let's fast forward to the point where the building process is completed. Now let's clear the terminal and build the TensorFlow wheel. Now let's wait till the building process is complete. If you list the contents of TensorFlow_pkg directory, you will notice that it contains the built TensorFlow wheel, which we can install using pip. So this was our quick tutorial on building TensorFlow from source. Thanks a lot for watching.